Good morning, Randy.
Good morning, Marshall.
Welcome to Tech Talk.
Yeah, our first topic today is going to be an exciting one that we get asked about a lot. It's a common misunderstanding area. It's around seismic systems.
We've got a couple special guests with us today. One of them is Patty Birch with Poly Processing Company, French Camp, California. Patty, you've been here 31 years?
31 years, yes.
And
Good
your
morning.
position with Poly Processing is?
Spec review and development.
Okay. And then, Randy, you have someone to introduce.
Right. We have John Audilano. Is that right, John?
That's correct.
I say his last name right. And he's with Lane Engineering. He's been a partner with us, Patty, for quite some
20
time.
plus years.
Yes.
Correct.
They're a structural engineering firm, and they do a lot with seismic. They're based right here in Tulare, California. Is that how you say it?
Yes, correct.
I know it's down by Fresno. I've stopped and seen you.
Yeah, I always say halfway between Bakersfield and Fresno.
There you go.
Or it's not the end of the world, but you can see it from there.
Well, John, we're happy to have you here with us, and we're excited to have you talk to us a little bit about seismic today and kind of what you do with us in our seismic systems. And we make a much better seismic system than I think anybody else in the chemical storage world. And we would like to talk a little bit about what's involved with all that today. And Patty, you've been running these systems for Poly Processing, kind of driving it with our partners.
Yes. Yes.
So one of the thoughts we would start off with is around the International Building Code, and I thought John could start us off with that. That's what drives a lot of this, and it's a constantly moving target. Is that right, John?
That's correct. So back in the day, there used to be a lot of different building codes, but I don't know, about 10, 15 years ago, they probably almost standardized them, made them into one set of building codes called the International Building Code, and each state adopts them. And so different states have different requirements, but California, especially California, is usually kind of at the top of it. And they adopt usually the latest standards. So every 3 years, that International Building Code gets updated. And so we're in this year, 2019, California is going to adopt the 2019 International Building Code, I believe it is. No, I'm sorry, the 2018 International Building Code. And in California,
Right, because the code is always a little bit behind whatever the current time is.
That is correct. They're correct. But then California adds all their amendments on top of it. And so then California adopts it, and that becomes like the model building code, and then California makes their own. So it's the 2019 California Building Code.
Right, and so the other states do a similar process?
That's correct.
And, you know, California's always been a leader here, of course, because of your geological data that you have to deal with here.
Yeah, especially with the seismic. So California's kind of always at the forefront of the building codes.
Yeah, it's definitely becoming, Patty, right, a thing all over the country. We're
Yes, we see it from all the states now.
And the interesting trend here, John, if you could speak to this, is it's becoming more and more address specific instead of just like what county or region of the country. How does that work?
Right. Again, going back before older building codes, it used to be just a map, and you kind of get in your general area, and you can figure out, okay, here's my seismic zone, what they used to call it. Mm-hmm. And now they changed it about, again, 10, 15 years ago when they went to the International Building Code. It changed a little bit. Now they go by specific area, and it's specifically latitude and longitude. And now, even with the wind, and going with the wind now, it's very site-specific as well.
So to catch everybody up with how we do it at Poly Processing right now, and this is already a differentiation from our competition. We ask when somebody calls in and they want to stamp seismic-wise, we have some standard systems, and we also kind of determine if they need something specific, and we work with Lane Engineering at that point. Can you go over how does that work for us when it comes to specific addresses?
Well, if a customer calls and they say they need a restraint, the first thing we want to get from them is the physical address so that we can put it in the system and see if the values are higher than our standard. And if they are, then we have to see what restraint we're going to have to use. And a lot of times it does change if the values are really high, especially in California.
And where do you get those values from?
We have a spreadsheet that we use that John has developed for us that we can put the information into.
And you check, I've seen also directly on the geological data
right.
From the government, right?
Right. Mm-hmm.
So we check that. That's where some of the numbers come from.
Well, we have a site that we plug the address into, and then it generates the values for us differently than the older site. Now it generates the S sub S and the S sub 1 that we need to put in the spreadsheet, and it goes from there.
And so that's good that you bring those up. Those are some of the values that you hear a lot, John. Can you talk roughly what those are about?
Yeah, so each location has its own spectral acceleration is what it is, and it's dependent on how fast or slow the ground's going to move during a specific earthquake. And so the USGS, United States Geological Society, they have a website that's mapped all these different acceleration values all over the continental United States. And with that, you can get your design seismic zones or design seismic acceleration factors for that. And just recently, they stopped publishing that data, and a couple other entities have picked it up though. And those are the ones we're starting to use now, and they're pretty good. They're pretty good ones. One's from ASCE, and they have, besides the seismic specific data for the SS and S1 values, they also have the specific wind values for that location too.
So the wind, and that's interesting. Now the wind comes into the picture, and just to keep everybody out there informed, Patty, can you differentiate for us what parts of our system are for wind and what's for seismic?
Yes. If the system is going to be outdoors, then wind is going to be involved. So when they tell us it's going to be an outdoor system, it generates a system with clips and cables. If it's going to be indoor, it's only for clips, except if there's buoyancy involved. If there's buoyancy, usually the cables have to be used as well indoors.
And buoyancy would be a concern if, like, it could become a flooded area.
Yes.
Okay.
Yes.
So, so the clips is mostly for the seismic, and then the
Yes.
cables for the wind when that comes into play.
Yeah, and that's correct, because in a wind event, we use the cables for wind uplift. So we look at two scenarios: when the tank is empty, and so the tank is just very, very light and doesn't weigh that much, and so the tank can lift up and move around, versus on the seismic event, the tank is full. We look at that tank is full because that's what's going to create your seismic mass in there. And then with the seismic mass, the tank is actually stable against overturning from flipping over. And so with that, it won't uplift. And so you don't need the cables. And the only thing we're resisting now at that point is just a sliding force. And that's with the restraints at the bottom.
So we do, in some cases, restraint systems for wind only, right?
Yes.
Not in California specifically, but other places in the country
Right.
where it's just a wind event and not a seismic issue, right?
Right, and the wind I know has been increasing, especially along the coastal. That was a big change in the last IBC code, right? Was that they upped, I think, the wind speeds from, I think it got up to 130 or so around the coastal areas, or where is it now, John?
I think it's up to 140, 150 miles per hour at a 3-second gust. But it's called an ultimate wind load, and so you can bring those down to a strength level or a stress level for us. But it's more code language there. Mm-hmm. But it is up to 150 miles per hour in some areas.
And what is coming with is this a part of the new 2019, or is it be the 2018 code we said, right?
Yes.
Correct.
In 2019.
Yes. It's actually, it's always been there, and we have used it in specific areas, because I think it might be even higher than 150. I think it can go up to 180, maybe 200. I have to look at the maps. I don't quite remember. But especially around the coastal areas in the southeast.
Right. So Patty, we always keep our systems up to date by checking in with John and Lane Engineering, and we keep our internal spreadsheets always up to date. So anytime a new quote is being requested, we're keeping current with the most current IBC code.
Yes, that's true.
So as these things happen, John, you just basically update our formulas and all the other things that go into making that determination.
That's correct. Yep.
So, John, one of the important things I understand from talking with you is how important friction is when it comes to making determinations around what a seismic system can be. And before I come to you, Marshall, I think, back in the day we did studies, polyprocessing did, on friction values. Can you speak to that?
That's right. So we had a third-party engineer that actually came in, did some testing at our facility with some tanks that were both empty and full, and looked at friction. The tanks being, using friction, and then also like being on a bed of marbles, I think, Patty, was that right? Something
That
like
sounds right, yes.
And we got to a point where we're using friction and have been for several years now, right, John?
Yeah, over 20 years.
Yeah, so I'm not sure who else has done that testing. I know the polyprocessing company has.
Exactly. I mean, if you're working with a design engineer on a seismic system and, your competitor can't provide a basis of, where their seismic calculations come from, friction's one of those really important elements that we've studied. And we've done that in the past with our plastic tanks. And now we're working with some other surfaces like foam pads. But we've done that for concrete as well, or you have concrete data?
Yeah, we have concrete data. And again, those friction values are very important, because without those friction values, there's no way we can do the simplified system that polyprocessing has. Just the friction, without friction, the seismic force, especially nowadays, the seismic forces would be very high, and it would be very tough to make a restraint system work.
That's an important differentiation right there of how intensely we look at a properly designed seismic system and what we've built from that. What I would like to do, Patty, is come back to that address point, because this, brings up some other questions, I think. But could you go back to the address thing? I know you're always making a point with our own inside application group to get an address when somebody's looking at a seismic quote. We don't always get that. We just get what state it's in.
Right.
But
right.
why is it that you're wanting that specific address? What does it allow you to do?
Well, for example, if they call and they say they're going to put a tank in one of the other states, like Indiana, Illinois, whatever. But if they call and they say they're putting it in Oakland, California, or San Francisco, California, or Long Beach, California, we definitely need an address because the fault lines are so much greater in those areas.
And so that also relates directly to what kind of a cost the system will be as far as
Exactly.
options go, right? You can
Correct.
look at different combinations of the robustness of the clip as well as the quantity of them and see what things can vary to give the best system package price.
So, like, for example, if it's a tank going, say, to Indiana, and it's not a very big tank, and it could take the smaller clips because the knuckle radius is smaller, then we could get away with 3 or 4 clips instead of 8 clips, depending on the tank size and the value of the address.
Yeah,
But without an address, we can't do that.
Right.
correct. And with the concrete too, the concrete can be a lot smaller thickness, or and then also the edge distance from the tank to the edge of the concrete can be a lot less too, because the seismic forces are so low down there or over there.
Right, and that's what you brought forth. Another thing we wanted to talk about a little bit is the concrete foundation itself. So when you're talking about the edge distance, can you elaborate on that a little bit more? What do partners need to be aware of when they're talking to a contractor and pouring a concrete pad? What are some of the key elements to keep in mind?
Correct. The anchor products nowadays have to meet very stringent seismic requirements, and so it's a very robust calculation now to do anchorage calculations. And the driving factors, there's 2 driving factors: the concrete thickness and the edge distance from the tank. Really, it's from the bolt, the center line of the bolt, to the edge of the concrete. But for ease of installation, we always measure it from the face of the tank to the edge of the concrete. And with those two items, we can, depending on the seismic values, we can either decrease the thickness of the concrete, decrease the edge distance, or use a combination of the two to get them down or up, just to make the calculation work out.
And again, that's going to be address specific in order to be able to look at that, right?
That is correct.
So Patty, when we provide the data sheets now, do we is that pointed out to our partners what that edge distance is?
Yes, on the bottom of the data sheet, it says how many bolts you're going to have to use, how much the embedment is required, and what the minimum concrete thickness is and the minimum edge distance.
Right. We group all that together because those are kind of the key elements
Right.
the contractor needs to
Right.
be aware of.
Now, when we're talking about concrete pads, do we also talk to them about what kind of concrete to use, as far as a slump mix or something like that, as far as the concrete itself?
Nowadays, we just go based on the strength of the concrete,
Okay.
and so the minimum is 2,500 psi is the base minimum. A lot of actually states, in certain seismic areas, you have to actually use 3,000 psi.
Okay.
But the higher the strength of the concrete, again, that's one of those factors we could use into play and reduce some of those thickness requirements, embedment, depth, or edge distance.
Okay.
So Patty, let's go back to more on this concrete base. When we're working with designers and want to know some of the application data that we need to kind of build a system around, there's a few more things besides the address that maybe need to be known. What are some of those things we want to consider?
Well, for example, if they have a facility that's already built and they have their concrete already in place, if they can tell us what their pad shapes are and the tanks they're using, then we can quickly see if they're going to have enough room to put the clips. Or if their pads are octagon or hexagon shape, that can be a factor on what we decide can work for them.
Because that goes into the clip to edge distance, right?
Right. And that's very critical. So the other thing is, like, if they say their pad's only 4 inches thick and we say the embedment needs to be 6 inches, then John's going to ask me what's underneath that, what's the foundation floor thickness, and then we can determine if we can use any of that or not.
Gotcha. So John, how is that important as far as the type of surface? Like, we've talked about concrete. Can somebody put a tank on, say, dirt or asphalt?
You could, but I couldn't do any seismic calculations for it. That's the important point, is because we have to have at least some testing data behind it in order to back up our calculations. It's not to say you couldn't do it, but to have a seismic set of stamped calculations. That'd be difficult, and we couldn't do that at this point.
Right, because to get that stamp, you're working off of known data, and that's something I appreciate about polyprocessing is that we're going to go in a safety arena where we know the results instead of guesswork.
That is correct. Yep.
So the other thing to talk about a little bit here with different types of pads are other pads coming onto the market. So we're working with a foam pad, which is a polyurea coated polyurethane foam pad. And so these are going to have different friction coefficients, but these also you can put a seismic system on?
Yes, yes, you can.
Okay, good.
But they have to be
tall clips.
tall clips because you want the clips to still get to the tank, right? Not
Right.
the pad has to cover the tank on
So
the pad.
typically our pads are about 4 inches in depth, and then the clip has to take that plus whatever is required for the height to make the clip work.
So even on the slope bottoms, we're looking even taller sometimes
Yes.
because we've got that backside that's really tall, and then the short side where the info is.
Right.
Right.
That's
So-
correct.
So these will be kind of custom systems that we'll get again based on a specific address. It'll have basically taller clips, and then the number will still be determined by kind of what that address is.
Same engineering concept, but it's just a different product that we're using, a taller clip.
And in a perfect world, we would rather prefer our customer to have concrete pads if
Yes.
they could, obviously.
Yes.
Because,
Yes.
again, you're talking about the expense of a pad that we're supplying versus a concrete pad. But then again, the clips and the seismic system could be quite a bit more expensive. Because
Very
of the tall
expensive. The
clips.
tall clips are very expensive.
Right. The other thing that can come into play to help somebody get a better system price on a seismic system would be, you were talking about it earlier, Patty, was the weight that's going to be on that concrete. John, what is our basis of design that we kind of calculate around as far as weight goes?
We use a specific gravity of 1.9, but that's just, I think that's almost one of the worst cases that
Yes.
polyprocessing does see for their chemicals. But we can, I mean, if it's water, we can go down all the way 1.0. So that's almost a 50% cut in your seismic forces.
Exactly. And then if not brought up otherwise, it has some service factor in there, for, engineers are always looking for that extra service factor protection.
Yes.
Right.
So, John, I want to ask about the spacing that the clips go around the tank as well. We need a little bit of space because obviously the tank expands, so we don't want it to kind of come directly in contact with the clip. And we say an inch is kind of the golden rule that everybody knows. But, John, you have a little bit of a way that some money can be saved, and there's a little bit of play there. Can you talk about that in the spacing of these clips?
Correct. We can always go to half inch. Of course, we don't want to go all the way to 0 because then there could create some stresses around the tank, especially when the tank bulges or expands a little bit at the bottom. And then from there we can go to so a good ideal is to a half inch, maybe all the way up to 1 inch would be the best.
And so if you went to a half inch, how would that save some money? That would be less concrete, possibly.
Yeah, correct. So I mean, it's a half inch all around the tank. So sometimes in these tight industrial environments, every half inch counts.
Exactly.
Well, one of the things that comes up on occasion are finite element analysis, or FEAs. And maybe you guys can talk, just Patty or John, why we run them and what the need is for doing those calculations.
Sure. Sometimes the specifications or just the customer's requirements, they want a design of the tank specifically. Normally, we're just designing the restraint system and not the tank itself. But the ASTM that the polyethylene tanks, polyprocessing tanks are designed for, only deals with hydrostatic loading. But so when they want to design the tank to specifically deal with wind or seismic forces, then you have to design the tank itself. And so we use a finite element analysis, just a fancy term for designing the tank, and we're using computer models. And with that, we can actually design the tank itself for the seismic and wind forces.
Okay.
So, Patty, on the FEA, I would like to kind of move the discussion a little bit into some things our partners deal with the specifications. And when we come into us, we have to review that and in the submittal process. Some of the issues we deal with there, FEA is one of these, right? Sometimes we'll see that the specification is asked for an FEA on the tank, or how does it get usually worded that we feel like an FEA is our answer?
If the spec basically says that calculations are required on the tank design, then that indicates to us that they will need the FEA.
So the way we would prefer it to be in our own spec language, so that it just has to be on the seismic system, would be how?
Would be saying that calculations are required for the tank's restraint system.
And not on the tank
and
itself.
not on the tank itself. But we can quote the FEA for them if the spec dictates that.
Exactly. So one of the people we now have in the room with us is our project manager, Brandon Hall. Good morning, Brandon.
Good morning, guys.
We invited him in because this is part of what Brandon helps us with is getting our submittals returned back and anything that we have to take exception to or elaborate on. And Brandon, what are some other issues that you see? I would like to start with one that you mentioned before, which is when the material of the Hilti bolt is called out.
Yeah, or the restraint clip itself. If it's not mild steel or galvanized steel or stainless steel, there's really, as far as my understanding goes, no design basis for being able to actually calculate that that material will withstand the forces that will be exerted on it. That's something John could help probably explain a little bit better. But we are, as of right now, limited with stainless steel anchor rods and either carbon steel galvanized, epoxy coated, or stainless steel actual clips themselves.
So if a spec called it for it to be something other than stainless steel, some other alloy, that would be something we don't have data on. Is that right, John?
Correct, especially for the anchor bolts. We use the third-party commercial vendors for the anchor bolts, and they have not tested their products for these other alloys. And so we always have to rely back on their reports and their testing values for the anchorage products, and they just don't have it yet. At least a couple years ago when I last checked with them, but it's always good to update and check again with see if they've updated their testing.
Right. We tend to work with Hilti bolts, correct? But there's some other options out there?
Yes, Simpson products is also out there. Redhead is another one. I'm sure there's plenty of other ones, but Hilti seemed to be always one of the ones that had a lot of good testing data behind it. But that's not to say that we couldn't use other ones. I was saying before that the anchorage product is actually a robust pre-calculation, and so we if there is going to be a change in product, we would have to redesign that anchor.
So Brandon, let's talk about some other things that you run into in either submittals or talk with Patty on spec design. What other kind of issues around seismic do you see?
A lot of times in the actual seismic section of a specification, whether it be in the general spec or a related section, a lot of times the engineer will refer to an incorrect section of the code. And I think that has, John, you can help me with this, a lot to do with it being a building structure or not a building structure. Is that correct?
That's correct. For our purposes, for the polyethylene tank restraint system design, there's two sections. We consider the tanks non-building structures, and that's in a certain document called ASCE 7, which is the model building code that the actual building code references. And so for non-building structures, there's a specific section in there that says tanks and vessels, and that's what we design our restraint system for. And in there, you can use friction, and it has values for all your seismic information you need to design the restraint system. There's a whole other section in that ASCE 7 document for equipment supported by structures. Now, that would be for your air conditioning systems, that would be for your architectural elements, all those different types of things, which we're not in that
Not a
realm.
freestanding tank.
Not a freestanding tank. The only time it comes into our system design is when we're going to be actually supported by a structure, when it's on the 5th story of a building or when it's on the roof of a building. But those are very, very rare events. Most of our tank designs are actually right on the ground level. So then we're actually at a non-building structure and a tank and vessel in that section.
Excellent. You know, John, with the stamps, let's talk about the stamps. You know, we often get asked for the wet stamp, and sometimes there's an alternative to that. Can you talk a little bit about what a wet stamp covers and, you know, what else is available?
Yeah, so with the technology nowadays, it's kind of what is a wet stamp, but back in the day, it used to be actually physically stamp it with your rubber stamp and sign it and then mail it off. And nowadays we can use an electronic signature, which is I just embed it in the PDF and then mail it off, and that's what we consider a wet stamp signature. If a customer does want a physical signature mailed to them, we can still do that, but most jurisdictions are allowing electronic.
And that'll be stamped, right, Brandon, from the state. It'll have a state stamp.
That's correct.
Yep, exactly. And the other option, too, is if an actual wet stamp is not required, as Lane Engineers, being a very good partner of ours, has supplied myself as well as others with the ability to provide a basic design, a data sheet that shows you the calculation. It just doesn't have an actual engineer stamp on it. So that is available as well.
And that's usually what you'll provide in your submittal data.
Absolutely.
Yeah, one of the things we get asked sometimes, John, is for an explanation of the calculations, which, of course, we are not in the business of teaching people your business. But there's a lot of science and a lot of, you'd have to go to school for a while to understand the calcs, as they say.
Yeah, the spreadsheet is an Excel spreadsheet, and just all the formulas are kind of hidden behind the spreadsheet. But we also provide a couple other documents with our calculations that is like a base of the design, the kind of our rationale of how the spreadsheet is actually calculating the forces.
Brandon, I think, did you have any others that we run into?
Actually, I just had one last one in regards to molded-in tie-down lugs. John, we have molded-in lifting lugs designed to lift an empty tank. What would be the difference in that regard?
Well, we don't never really design for the lifting ducts to actually hold for a seismic or a wind event. It's not really something we would want to do. From what I understand, too, sometimes when the tanks is filled with the mold, it doesn't even completely fill in sometimes. And there's always just been designed for the empty weighted tanks. I don't think it'd be prudent to use it for the design of the restraint system.
Well, this is really good having you here today, John. Obviously, I think you helped our partners get a sense of how thoroughly we look into seismic. I guess the thing I'd like to end on a little bit is talking about how we can customize PADI to any kind of situation. And so a lot of these are standard systems. We have in our regular spec language some general recommendations around seismic. But when customers run into something specific, we're willing to look at that custom. And you have some examples of this.
Yes, so if a customer has a pad that's not big enough or is not thick enough to meet our standard, we can present those measurements and the tank type, the tank weight, everything to John, and he can help us to either come up with a system that will fit or design a unique system that we can have built.
Right. I remember there was a situation where you were telling me we even had somebody that wanted their specific wind speeds and calculated around an exact wind speed.
And
John,
we can
you
do
helped us
that.
out with that.
Yes.
Yes.
So, John, you'd be willing for us to bring a customer on the phone from one of our partners if they had a city that had like special concerns around this and how the seismic system, we could get into a conversation with you.
Yes. I mean, I always pride ourselves on customer service too, so I'd be always willing to talk to somebody.
And it's why we really appreciate you as a partner. We, like everything at Polyprocessing, want to build a very safe and long-lasting system. So we partner with the best in the business. And John, thanks for being here with us.
Thank you for saying that.
Well, as we come to a close, we want to thank our special guests again, Patty Birch and John Adelano. And Randy, this has been good hanging out with you, and looking forward to the next Tech Talk.
Yes, I'm excited. We're going to have one on NSF 61, and we have some other good topics, so everybody should stay tuned.